probably the most interesting thing in the conference, which is mobile games. Using Python to make games on iOS and Android.
Cool.
Say hello.
Hi everyone, and yeah, apologies for the hiccup. There's always one, well actually two, but there you go. It's us. The most interesting thing in the conference. I'm speaking first, then Fiona's speaking. Actually, Fiona's speaking about the most interesting thing, so I'm just like the leader.
It's not true.
So there we go. So we develop games. Now we don't develop games as you know it. There's a bit of a twist. We develop something called psychometric games. Has anybody here taken a personality assessment or a psychometric test? All right, fantastic, cool. So you know what it's all about, boring questions and all the rest of it. Actually, what we do is develop games, and based on the way you play the game, we analyse the data that comes out of the game, we collect the data, we tell you all about yourself. Actually, we'll tell all the employers about. So, what do we need from our games? So this is right from the start. We think, right, we're going to do this. What do we need? Well, we need sort of an attractive game interface, the usual story. We need to develop rapidly and easily and distribute it and all the rest of it. Critically, we wanted to target graduates. So in doing so, we actually spoke to a company that specialises in recruitment of graduates, and they said, if it doesn't happen on one of these, it doesn't happen. So it's just like, well, basically, we know what we're going to do. We're going to develop a lot of ice games. And this is a screenshot from one of our games, and all screenshots actually. And it's on tools, which is great. So, we realised we're in good company. Developing mobile games, I presume most people here have a smartphone, quite a few probably have games. It looks like that games on the App Store is the thing. In fact, every 2 to 3 minutes, a game is put on the Apple App Store, which is sort of mind-blowing actually. So, we knew what we were going to do, and we had to make some decisions. So we need to decide what tools and frameworks to use. Now, no surprises, we're at such Python conference here, but let's go through the thought process. Sane games developers use one of these tools. Simple as that. The problem was none of these were Python. Also, they're proprietary, and we're slightly sort of veering away from that. And yes.
Doesn't Unity have some Python thing?
Good question. Long answer.
Not really.
We'll leave a long answer then.
Yes, fair enough. No, certainly not first-class citizen, and certainly not second as well, so that was an issue, but yeah, good point.
As an aside, this one's really good and you should all use it.
That was sarcasm.
No, no, I use it.
But we didn't. So, seriously though, why should we use Python for games rather than just because we do Python? Well, actually, when it comes to psychometric assessment, psychometric tests, there's a lot of work that goes into making sure that it has psychometric validity. So, we are constantly tweaking the game, testing it, tweaking and testing, and it's just constant iterations. But to have to do that in a language which isn't so suitable for rapid development would be a real pain. So, yeah, Python makes sense here. What else? Actually, we knew we were using Python on the server. We use a lot of Python and pandas and scikit-learn for our data analysis to give us our psychometric results. So wouldn't it be great if we had full stack Python? Also, Fiona, big games developer, had already written a great open source
Sorry,
framework.
did you just call me a big games developer?
Big into games development, had just written, I'm going to make trouble now, had written an open source framework for rapid development 2D games. So perfect fit for us. Rapid development in Python, and we want to target mobile devices. So great. Here's the other reason. We just wanted to do it. And actually, it reminds me actually of a story that, no, it's not a story. 2007, and I was in a tutorial at PYCON UK. It was John Pinner giving a talk about his system called Paytime. I don't know if you remember it at all. It was a payroll system. And he asked everyone in the room, look, most of the code's in Python, but the calculation module is in C. Can anybody tell me why? People gave all sorts of reasons. I said, oh, because you want to have complete control of the accuracy. So don't be stupid, that's rubbish. He said, because the person who's developing the calculation module's first language is C, so you wrote it in that. So actually, there are reasons why you might write it. If your developers are Python developers, then you try your best to try and do the match. It doesn't make it right.
Don't be like Miss Stubbins.
So, what did we do? I'll try and guide you through this. We chose Kivy. Possibly everyone here has heard of Kivy. It is the poster child for running Python on everything under the sun, apart from the browser. So it was a natural fit. And here is a very simple Kivy app. It's very simple to use. Creates an app, creates a button, that's the callback thing going on, and you get a nice window with a button. And that looks exactly the same on Android and iOS. So what's not to like? The problem was, initially, It's the only viable option, and that always rings alarm bells. So we knew in choosing that, we were going down a road we couldn't come back from. So worried about that. So far, it's been okay, thankfully. The other problem was buttons, sliders, all that sort of thing, scatter widgets. I think Kivy is based on around multi-touch and UIs basically. And we don't want that. We want not this, but this. We want to be, talking about sprites and colour and collisions and all that sort of stuff. So Kivy wasn't necessarily good for it. But then enter Myrmidon. So we have Kivy, we have Myrmidon, and we made the two work together. Fiona will talk more about that later on. And this was our very first mobile app. This was sort of early last year, and I think Fiona sent me an APK and we ran it, and it was just like screens all over the place. It was fantastic, a really good moment for us. And then, yes, we just couldn't help ourselves. We just put whatever we did under the sun just to show that we could.
That's an iPad, that's an iPhone, these are all Android, and there's a desktop machine. It's running the same code.
Exactly, so Kiwi's great for that. So, it's the same code. The same code runs on both Android and iOS. I mean, it's wonderful, it just works. The only thing you don't get for free is all the stuff that's quite phone specific. It's not built into Python. Python's battery is included, but not for mobile devices. But not an issue. We do access some of that, and there are some great libraries that allow you to do this. There's a sort of high-level library that literally is cross-platform for accessing stuff like accelerometer, and the battery life, and all the rest of it. And then you've got these low-level language, great names, PyObjus and PyPyGenius, I think that's pronounced, which are just Python bridges to Objective-C and to Java. Oh, and here's some code, because I'm not showing you some code yet. I'll just show you some Kivy code, but it's great. It's a bit like sort of C-type, CFFA, I-type stuff. I mean, this is an Android Java class. You literally wrap it in this thing called auto class, assign it to something, and then just use it as a sort of standard Python object, which is wonderful. And exactly the same again in for iOS. So, next thing, deployment. We found out, we realised we could deploy things, but it's only when you actually come to deploy it for real that you realise that there's sort of issues. We've worked through them now, but there's two completely separate deployment systems for iOS and for Android. This shouldn't sound surprising when they're two completely different systems, but we had hoped there would be some sort of unified system for deployment. There was, but now there isn't, and it was a bit of a mess. Thankfully, it's gotten a lot better. The one for Android is called Bulldozer. I think it's a bulldozer.io out there for Android development, if anyone knows it. It's not that, it's called Bulldozer. And you have a spec file which lists all the libraries you want compiled, then it cross-compiles Python and all of those libraries, and then spits out the APK, and then you just upload it to the App Store. The problem is, it's this all-encompassing system that downloads all sorts of stuff from the internet and constantly updates itself when you run it, and sort of self-bootstraps such that each time you build, you get something different, and then it breaks, and then you have to fix it, and it's a pain. And Kivy for iOS is the build system for iOS. It does a similar sort of thing. You have this concept of recipes. You have a recipe for Python, a recipe for SDL, whatever other libraries you're using, and you cross-compile. This time, it spits out an Xcode project. Once you're in Xcode, you're great. You stick in your icon, stick in this, and when you can use Xcode, that's all you do. Again, it itself is a moving target, but recently it's actually become quite solid and it seems to work quite well. Next painful thing was, I don't know if you can see, you can't see all my laptops and everything, but none of us are happily Mac-type shiny developers at all. So we're suddenly faced with iOS and Xcode and having to sort of sort all that out. We didn't even have a Mac. So, we swallowed our pride and went out and bought a second-hand Mac, and we couldn't even get that right. We couldn't even get that right. They sent us an AZERTY keyboard. It's just really quite painful. And we've not actually changed the keys over because we're proper developers and don't need to look. So,
Still can't work out backslashes.
No, we're not, exactly. I'm going to have to rush through this, but pain number 5 was alpha blame. This was the only thing that didn't work quite right between iOS and Android. So, lovely, we've got the screens come out, and then we looked a little bit closer. If you look at the jars over there, and I don't know if this is familiar to anyone at all, but look at this beautiful sort of alpha around here in the glow of the jar, and this is quite ugly. The more we looked at it, it was very ugly when it came to iOS. Problem is, pre-multiplied alpha, does anybody know what that is, or understand that? I'm sure you do.
Standard in video games.
I mean, absolutely. So, you probably know what red, green and blue components are, and you have sort of the alpha side of things. And at runtime, it says, oh, what's the alpha? Well, let's just multiply the value of the alpha by whatever the red, green, and blue are to actually end up with the red, green, and blue, which is great. So these are 1s and effectively become at runtime 0.3 in this case. So a bright spark, and there are all sorts of reasons why you might want to pre-multiply alpha, partly for performance, partly because actually you might end up with a better result, but that's beyond the scope of this talk. Why not just multiply it beforehand, before runtime? Because you're going to have to do that anyway at runtime. So here we go, 0.3, 0.3, 0.3, and then when it's littered to the screen, just ignore the alpha. Fantastic. Unless Kiwi takes the Kiwi takes the pre-multiplied alpha and then multiplies it again at runtime. So what you get is 0.3 times 0.3 times the 1, and that's why everything goes dark, and that was a nightmare. The thing is, Xcode just pre-multiplies everything, and you cannot switch it off. There's even settings to switch it off, and you can't switch it off. So yeah, exactly. So some gymnastics inside the Myrmidon code actually to try and get. In fact, we tried to play with png.py, great Python library, maintained by this guy over there. The problem is that the images would take 10 seconds to load by using Python to do it. So we fixed it in code eventually. Some other issues: performance, not fantastic. Kiwi on the devices, Python 2, not Python 3. On desktop, it's Python 3. When you get into Xcode, you've got all sorts of things that help you, but you're developing outside of Xcode, so you don't get that goodness as well. And actually, you'd think it's easy to find game devs who want to do Python, but they all want to do Unity. No. And now it's Fiona.
I'll load it up there.
Yeah.
Do you want to plug it in where I'm opening it?
Everything's fine. Nothing to see here.
Oh, sorry. Right, Safe's really good at this whole public speaking thing, and I'm not, so I'm compensating with cat pictures. So yeah, I made a generator-based game framework in Python, and I'm going to talk about why I did that. So as a very prehistory of how I eventually decided to write this, I've been writing code and games for a very long time. This is a genuine baby picture, I promise. And I started out with C++ and writing text adventures and things like that. And eventually I discovered this piece of software called Div Game Studio, and I suspect nobody has ever heard of it. Nope, didn't think so. It was an old DOS program, and it looked a little bit like this, and it was an all self-contained workflow, and it had a really interesting language that was a little bit like Pascal, would you say? Yeah, and it had a very unique mechanism for doing its objects. But because it was DOS, and because the company eventually disappeared, and it wasn't supported, one day, Windows XP killed it for me. So nobody could play my games, I couldn't really use them anymore, and I had to move on. And I moved on to various languages, and I have a thing where every time I learn a language, I try to work out how to make a game in it. And none of them really felt right, because none of them worked how Div did. So I moved on to Java, and I used Java, and that was a really dark period of my life. And then I moved on to Python, and Python is fantastic. And I love Python, and I super fell in love with Python. Python is great. And this was years ago, I've no idea now. But you never forget your first love. And I especially never forgot it because it worked in a very specific way. And no matter how I tried, whenever I tried to write games, none of it really felt like it worked correctly. And then one day, I discovered yield. And suddenly I could put a name to the way Div worked. And how it worked is all its objects were coroutines or generators in terms of Python. And I got really excited. So let's talk about game objects as generators. So first off, let's explain that when you have game objects, typically in games, they have little bits of code that will explain their logic. And they're little independent bits of code, and every time, every frame, you'll want to update each object by running an update method or something, and it'll just be a function that runs and function and function, and it just works as you expect it to. But generators work a little bit differently. So hands up if you don't know how generators work. Yes! Okay, so I had a really dumb thing that showed how generators work by just basically explaining that they're functions that you can run, and then when you go and run next on them again, it will go back to where they came back from. So I don't even need to go through this, it's fantastic, great. Okay. so let's go through a small example of how generators can help us write something that looks a little bit simple but is actually fairly complex when you think about it. So here's Snowball, and let's watch the path Snowball takes. Goes down and then takes some steps and then he goes down again. That's a fairly simple animation. So I wrote a bit of code, and this is some code that doesn't use generators, but it's an example of how you might write that animation. And it uses a state machine, and it keeps track of the animations, because every frame has to go back into this piece of code from the top. So work out which state it is, where the animation it is, how far away through it is, and all that crap. And this is all awful, and forget about it, because it's not a good way of doing things. So, oh, there we go. So here's a mechanism for doing it if you had generators. So the way the entity code for this works is, instead of having a method that you call every frame, you instead have a generator that represents its current state as it currently is, and this is the code that you will run every frame. So every frame you'll come into this generator. So it means that to do our animation, we'll start at the top and we'll just move down, and then and it will obviously just keep coming back to here every time you run the method. Run the generator, and then so that moves down, and then we do the steps, which is step up, step up, step up, and again it's just simple sequential animations. We go this thing, then this thing, and then this thing. We move down and run it, and you end up with, oh, sorry, Snowball. There we go. Snowball does his thing. Snowball. So I hope that convinces you, maybe, that generators make it a lot easier to do animations. So when you play a game, you'll see things fading in and popping and moving and spinning, and those things are such a pain in the ass to do. And those things are what add the polish. And if you're using generators, adding them is just no problem at all. It's really, really simple. So, me convinced generators are the best thing ever, and me finding Python will actually support them means that I then went ahead to make a framework to write games with it, because nobody else seems to be doing this. I have no idea why. So I made the same mistake 3 times. First time, I wrote a library, and it used Pygame. Pygame's cool, but its rendering is kind of slow, it's all software-based, and it's not great. So then I discovered, this doesn't work safe. Then I discovered Piglet. Piglet's a lot faster. It uses OpenGL for its rendering. So I wrote a second framework, and that used generators, and underneath it used Piglet. But then I kind of decided I really want to use full OpenGL, so then I wrote a third engine, and I just used straight up OpenGL and forgot about Piglet and all this stuff. So now I have 3 engines that I wrote from scratch, all using the same paradigm. So then I started working on Myrmidon instead. So in Myrmidon, game will interface with the main Myrmidon engine, and this contains all of the entity stuff, all the generators, and all the way everything like that works. And the core engine will talk to interfaces that handle window handling and rendering and input and audio. And because I'm really, really finicky, and I know that I always want to keep trying new technologies, I then wrote boxes that these talk to. So this could be a Pygame thing that does rendering, does window handling, and this could be an OpenGL thing, and that could be some other library, and who cares? Because this stays the same, and it doesn't mean I have to keep redoing the same stuff. And what I have to keep doing is filling in these boxes every so often. And as we'll come to, I've had to do that a lot. So Myrmidon isn't just a pie in the sky thing. It's actually quite a big library, and I've added shit tons to it, and it's really got a lot in it. Everything from your images and your entity crap and timers and math routines and screen fading, and God, it's just, there's a lot there. I was overdue a cat, I think that's what that's for. So then we come on to mobile platforms, because at this point, Myrmidon is a desktop engine only. And Safe came up to me while I'd already started my job and writing desktop games, and he said, so we kind of need these to work on mobile. They need to work on Android, and they need to work on iOS. And I looked at him a little bit gone out, and I was just like, I don't know about that, but we'll see. So it turns out that this guy's really cool, and there's about like 3 or 4 libraries for interfacing with Android, and they all work really well, and they're really great. This guy's not so cool. This guy should go in the bin. So it then turns out that there is basically one game in town when it comes to doing cross-platform mobile stuff, and that's Kivy. And Kivy has lots of nice things for building your APKs and your, what are they called in iOS? IPAs, yeah, just the packages. It does all the packaging for you, and that is most of the hard work. Most of the hard work is not getting things on screen and getting things to work. It's actually packaging things up and then sending it to Google or Apple and hoping it works. So Kivy did all that for me, especially Kivy iOS. So these guys are great. Unfortunately, I think that project's a little bit decrepit these days, but it does still work, which is great. So yes, it worked, and we have games on the iTunes App Store and the Play Store, and they're all pure Python, and they all work really well. So then, not too long ago, Safe shows up, and he's like, clients are kind of telling us that you need to be in the browser. And I'm like, really? So I then investigated doing browser stuff, and spoiler, I did give up on this. But it's not all sadness. The brief was to make sure Myrmidon games can work on web browsers even though they're made for desktop. So first I looked at Brython, and Brython is a re-implementation of Python in JavaScript, and it's pretty cool. It runs really fast, and I quite like it, but the Python implementation is not perfect CPython at all. In fact, it has so many differences with normal Python, it was a no-go for us. And in fact, we also found bugs in the way the generator worked, so we were just scared of it after that. Then I eventually found PyPy.js. PyPy.js is basically PyPy that has been built using ASM.js and runs in the browser. So you basically straight up have PyPy running in the browser. And I got it working. I had a piece of code that was I had a game where it was things on the screen that were all moving about that used the same Myrmidon code that you used to write on the desktop, and without any changes, showed up in the browser, and everything was working great. But part of the problem is that all our clients said it needed to work on mobile browsers, and this is the point I gave up. Because the problem is that it was fine on the desktop. It took about half a minute to load up, which is perfectly fine, because what was happening is that it was loading Myrmidon, and then Myrmidon was loading loads of other standard library stuff, and it was all just loading. And it actually took 3 minutes to start up on mobile web browsers. It worked, but it meant that our clients and players would have to sit there for 3 minutes looking at a loading screen, which was just a complete no-go. So I decided that I couldn't really get it much better than that. So maybe one day, maybe it'll be faster. So now this point is my cry for help. So yeah, Myrmidon's kind of my little baby, and I spend a lot of time improving it, and it's kind of become an important part of my day job as well, strangely. So I've used it previously for various projects, for game jam stuff, and obviously for my day job and for other personal projects, and I'll continue to use it. But it's not without its problems. So there's a load of issues on GitHub, and as long as my arm, and to be honest, I can't bother to work on, there's more important things to do. There's a few API holes in there. More specifically, there's no real good audio routines. At the moment, you ask it to load audio, and it just gives you back a handler for whatever backend you're using. And the OpenGL renderer uses immediate mode, which means it's not as fast as it could be, it's not modern, no shaders and all that stuff. I will make that better one day. But worse than that, there's no documentation. The thing is organically grown, so yes, there's no documentation. So my cry for help is that on Monday, I'm doing a sprint session. and the sprint is to improve Myrmidon, more specifically docs. So I'm going to sit there writing docs, and if you want to come along and help me improve it, that would be great. If you don't want to help me improve it but are still interested in it, I'll be happy to go through the engine with you and the